In this video, we will demonstrate 3 different ways to calibrate a differential pressure gauge and the pros and cons of each method. In this example, we will use an Additel 901 pump to generate the pressure. The Additel 681 differential gauge will be used as our accurate reference, and we will be calibrating a Magna-Helic differential gauge that is 0 to 10 inches of water. For this method, we will connect the high ports for both the reference and the device under test, or DUT, to the 901 pump, leaving both low ports open to atmosphere. Most all Additel pumps come with easy-to-use hand-tight quick connectors that do not require the use of PTFE tape or wrenches. The Additel 681 differential pressure gauges also connect with easy-to-use quick connectors. It is important that the DUT is in the proper orientation based on its application use. This gauge was calibrated and used in a vertical position, so we will calibrate it in the same orientation. For many analog gauges, it is good to exercise the gauge to its full scale 1 or more times prior to taking calibration points. First, we need to zero the reference. We could also zero the DUT if it allows for a zero. Because this is an analog gauge and is not normally zeroed in application, we will not zero the DUT for calibration. Now we are ready to generate pressure and record our results. Typically, 3 to 5 points are taken, both ascending and descending. By taking more than 2 points, we are able to check the gauge's linearity and hysteresis. To achieve cardinal points in the gauge, the high-quality screw press or fine adjustment knob may be used to dial in the exact pressure for the gauge. The Additel 901 pump uses an isothermal bellow chamber, which is designed to reduce the impact of environmental temperature changes. In this method, the setup is very simple and the equipment used is relatively inexpensive. However, this method has some considerable disadvantages. First, because the low or reference ports are open to atmosphere, the change in barometric pressure needs to be accounted for. Depending on the calibration environment, this error can be significant. The influence of temperature effects also presents a challenge with this method. This is the least accurate method of calibration. In this example, we use an Additel 912 pump to generate the pressure. The 901 pump could also be used. However, the 912 is better able to handle higher ranges and higher volume instruments for this type of setup. The Additel 681 differential gauge will be used as our accurate reference, and we'll be calibrating a Magna-Helic differential pressure gauge that is 0 to 10 inches of water. For this method, the high ports of the reference and the DUT are connected to the 912 pump. The low port of the reference gauge and the DUT are connected together, which greatly reduces the influence of environmental errors. Just like the previous example, the DUT orientation is still important. We will exercise the gauge a few times before starting the calibration. Recording the 0 point may vary depending on the type of DUT. If the DUT is a digital gauge, then keep the reference gauge and the DUT reference ports connected together and zero both gauges. In this example, I have an analog gauge, so I'll disconnect both the reference ports and leave them open to atmosphere to zero the 681 reference gauge. After recording the 0, we will connect both reference ports together and proceed through the calibration. Now we are ready to generate the pressure and record our results. Typically, 3 to 5 points are taken, both ascending and descending. By taking more than 2 points, we are able to check the gauge's linearity and hysteresis. In this method, the equipment is relatively inexpensive and does a much better job accounting for errors caused by changes in the environment. By having the low lines connected together, the measurement is more stable at each point. This setup is more complicated than the first example. For this example, we use an Additel 761 LLP automated pressure calibrator as our pressure source and reference. we will be calibrating a Magnehelic differential gauge that is 0 to 10 inches of water. The outlet port of the 761 is connected to the high port of the DUT. Then the reference port of the 761 is connected to the low port of the gauge. To exercise the gauge, simply enter the full scale pressure and press enter. The 761 will supply pressure through a built-in pump and control to the full scale. To decrease the pressure, simply press vent. With the 761, pre-programmed tasks can be set up and stored in the calibrator's memory. I've created a 5-point test with the specifics of this gauge and saved it as a task. I'll select the task and then select Run to start the test. After confirming the environmental conditions and how the test is to run, press Next and the test will begin. The test screen is set up to display the pressure of the 761, which turns green when the pressure set point is reached and is stable. The highlighted box is the reading of the DUT. The 761 is set up to default the DUT readings to the set point pressures. This allows you to make micro adjustments with the 761 to adjust to the cardinal point and press enter when the cardinal point is achieved. Of course, manual entries of the DUT can also be put in if that is the preferred method of processing the results. Once the test is complete, the results will be displayed with the choice to record the results as found or as left. Any results that are out of tolerance are colored red. In this case, my gauge is in tolerance, so I'll record the results as left. Although the equipment used is more costly than the previous examples, this method can be fully or semi-automated depending on the DUT. Measurements are controlled and stability is ensured by the calibrator. The 761 is much less influenced by environmental changes than the previous example, and the results are automatically displayed and calculated. If you are to be calibrating a transmitter, the 761 is designed to fully automate the test by reading the electrical output of the transmitter and recording the pressure from the calibrator. We hope that you found this application video instructional and useful. For more information, please visit us at additel.com.